Lesson 2.9, Weighted Averages. In this lesson, you will learn to solve mixture problems and solve uniform motion problems. Some vocabulary include weighted average, mixture problem, uniform motion problem, and rate problem. Okay, before we get into this, there's one thing we need to understand. We need to understand what an average is. So, if you remember, if I wanted to find the average of all the numbers, so I say I had 2, 2, 3, 4, 4, and 5, right? So average, you add up all the numbers, and then you divide by the number of numbers you have. So in this case, I have 6, and you would find the average that way. So if you notice, sometimes there's a repeated average. So here I have 2 2s, so I can say 2 times 2 plus that 3. And then there's 2 4s, so I can say that's the same thing as 2 times 4 plus the 5. And it's still divided by 6. Okay, so this is when you have like kind of a repeated average. That's one type of weighted average. So we're going to use that to solve some of these problems. So our problem is this. Mandisha feeds her cat gourmet cat food that costs 1.75 per pound. She combines it with a cheaper food that costs 0.5 per pound. How many pounds of cheaper food should Mandisha buy to go with 5 pounds of gourmet food if she wants the average price to be $1 per pound? Okay, so we don't know how many pounds she's buying of each. Well, we know she's buying 5 pounds of the gourmet food, so that's the 175 per pound food. So we know we're going to do 175 plus the 175, and we're going to do it 5 times. But to keep it simpler, we're going to do 5 times the 175. So in the top, right? And then we want to know how much she's going to buy of the cheaper food. We don't know. So we're going to call it X, and the cheaper price, 0.050. Okay, so for the total amount that she bought of bags, she bought 5 that were 175, so there's 5. And we still don't know how many she bought of the other one, so we're going to call it X. And they say the average is $1. We want the average price to be $1 per pound. So it's going to be 1. Okay, so then I just want to solve this. So I can treat this like a proportion and do cross multiplication or get rid of this by multiplying. So I'm going to get 5.5 times 175 minus 0.5x equals 5 plus x. And then I want to get, well, let's simplify this first. So 5 times 175 is 875 minus 0.5x equals 5 plus x. So I want to get the variables together and the constants on the other side. So subtracting 5, I get 375, and adding 0.5 to both sides, I get 1.5x. So dividing both sides by 1.5, I get x equals 7.5 pounds, and that's our answer. So she should buy 7.5 pounds of the cheap food so that the average comes out to be $1 per pound. Okay, we can do the same process with percentages. So a car's radiator should contain a solution of 50% antifreeze. Bay has 2 gallons of 25 or 35% antifreeze. How many gallons of 100% antifreeze should Bay add to his solution to produce a solution of 50%? Okay, so we want the average to be 50. So using our average thing, we want it to come out to be 50. And we know that he has 2 of the 35, and we don't know how much of the 100 he's going to use, or she, I don't know. So the total that he's adding of gallons together is going to be 2 plus x. Okay, so then we're just going to solve this by multiplying both sides by 2 plus x. So when we do that, we get, simplifying the top up here, that's 70 plus 100x equals 100 plus 50x, distributing that 50 through. Okay, so combining, getting terms on the right side, I'm going to subtract 70 from both sides, and I'm going to subtract 50x from both sides. So here they cancel, I get 50x equals 30, and they cancel there. So dividing by 50 to get x by itself, I get x equals 3 over 5, which is the same thing as 0.6. So it will take 0.6 gallons to get to a 50% antifreeze when you add 0.6 gallons of 100%. Okay, so we also want to be able to find the speed of one vehicle. So Nita took a nonstop flight to visit her grandmother. The 750-mile trip took 3 hours and 45 minutes. Because of bad weather, the return trip took 4 hours and 45 minutes. What is her average speed for the trip? So we want to figure out her average speed for the way, and then we want to find her average speed for the way home, and then we can use a weighted average to do that. So 750 miles, and she did that. So remember, distance equals rate times time, or rate over time. Rate equals distance over time. We'll do it that way because we're trying to find the speed. So rate equals distance over time. So the distance was 750 miles, and the time she did that was 3 hours and 45 minutes. So 3 hours and 45 minutes is 3.75. 45 minutes is 3/4 of an hour. So that's 0.75. If we're to say it in hours as a decimal, so 3.75. So when we do that, we get 200 miles per hour. So that's for the way. We also want to find the rate on the way home. So she still went the same distance of 750, but this time her time was 4 hours and 45 minutes. So that's 4.75. So when we do that, we get 157.9 miles per hour. Okay, so if we want to find the average for the way there and the way back, we can't just use this because she was going this speed for a shorter amount of time than she was going this speed. So we have to use weight. So the way we're going to do that is we're going to do the rate times the time. So time is like the number of times that this thing occurred for the way, and then we're going to do the rate times the time for the trip home. And then it's going to be over the total time. So when we do this, we're going to do 200 times 3.75 plus 157.9 times 4.75. And it's going to be divided by 3.75 plus 4.75. So simplifying the top, when we do that, we get 1,500. And when we simplify the bottom, we get 8.5. So 1,500 divided by 8.5, we get 176.47 miles per hour. So that is her average speed for both trips. Okay, and we want to apply a similar concept with this last one. A railroad switching operator has discovered that two trains are heading toward each other on the same track. Currently, the trains are 53 miles apart. One train is traveling at 75 miles per hour and the other at 40 miles per hour. The faster train will require 5 miles to stop safely. The slower train will require 3 miles to stop safely. About how many minutes does the operator have to warn the train engineers to stop their trains? Okay, so if we're looking at this, we've got one train heading this way. Oops, he's going. And we've got another train going the other way, and we don't want them to crash. So this guy needs 3 miles to stop. So let's say it's over here, he needs 3 miles. This guy needs 5 miles. So altogether, 8 miles is needed to stop, which means if they're 53 miles apart, if I do 53 minus 8, I'm going to get how many miles they have to travel. So 53 minus 8 is 45. So they have 45 miles to stop. Okay, so that means that if this guy is traveling 40 miles per hour, the number of minutes he goes is how many miles he's going to go. So the number of minutes times 40, and the number of minutes or the other guy who's going 75 miles per hour. Altogether, they're going to have 45 miles. So their rate times the time will be the distance. So this is the rate, and this is the time, this is the rate, and this is the time. And this is going to be the total distance. So since they have the same amount of time for both, they're like terms, we can combine them and say this is 115m equals 45. And then we want to get m by itself. So divide by 115. And we get m equals 0.39. But this is in hours because these are measured here in miles per hour. So that means our answer is in hours. But we want to know how many minutes. So to get from hours to minutes, we're just going to multiply by 60. So when we do that, we get about 23 minutes. So he has 23 minutes to warn them to stop their train so they each can stop. Okay, that is the end of this section. I will scroll through the problems at the back. Feel free to go through them and try them out.